The effectiveness of a web application tester is determined by his or her knowledge of the protocols used by the application being tested, and the key protocol to learn about is HTTP. HTTP is a stateless client-server protocol. In other words, each HTTP message sent stands on its own and has no implicit knowledge of any previous messages. We're pretty familiar with using a software application called a browser to access web applications, but HTTP messages can also be sent programmatically and from appliance firmware. In fact, HTTP can even be hand-constructed and sent across a telnet connection. Assuming we're using a browser, we'll put in an address known as a URL, a universal resource locator, which can be looked up in a directory, typically a domain name server, to find the internet address of the web server. The URL will either start with http:// or https://. By default, an http:// URL will establish a TCP connection on port 80, and HTTPS will establish one on port 443. We can override this by placing a colon and then a port number after the main URL. It's not unusual to see a web server set up on a different port. The web browser will then create an HTTP message and send it to the web server. The web server will then reply as an HTTP response message. Let's take a look at a typical HTTP exchange using Wireshark. I recorded a browsing session in the Hack Me Casino using Wireshark. It's open, and we can see at line 91 the start of the three-way handshake for the connection to port 3000 on 10.0.2.10 with a randomly assigned browser source port of 54472. I'll right-click and select Follow TCP Stream to get a trace of this session. The first packet we see is an HTTP GET request. It starts with the line get/http/1.1. This instructs the server to send back the default startup page in the root directory of the web server. GET is one of 8 standard request commands or methods defined in HTTP. The GET command allows a user to download a web resource from the server. This will often be a web page specified by a file name. Omitting the file name will cause the default first page to be returned. The head request is used in the same way as a GET, but will download just the header or metadata. This is commonly done to check the last modified date of the page, to check against a local cached copy. The POST command allows a user to upload items to the server. This is commonly used to send form data to the server and is the key message that's of interest to pen testers. The trace command requests a diagnostic trace of the actions taken by the server. The options command asks the server to return the list of request methods it supports. The connect command causes the proxy to connect to another host. This is often used to make an SSL connection through the proxy. The protocol also allows for the put command to send data to the server to be stored, and the delete command to delete the data. These are often not used in production systems for security reasons. Back to Wireshark, and the next line indicates the host name of the web server and is a repeat of what we entered into the browser, host 10.0.2.10 3000. Following this, we see the user agent which has been used to send the GET request. In our case, this is a Mozilla Gecko Firefox browser running on Linux. The browser then indicates what it can accept as a response, the format of the message, the language, and the encoding options. The final line says connection, keep alive. This enables the connection to be kept open for multiple request-response pairs. But at the content level, it's still stateless unless we have a way of maintaining state, usually a cookie. Keep alive is the default in HTTP 1.1, but in this case, it's being explicitly stated. The web server returns an HTTP response, which starts with the line http:/1.1 200 OK. There are 6 common status codes. 200 indicates that the request was processed without any problems. 400 is a bad request. 401 is unauthorized. 403 means access is forbidden. And 404, an unknown page. 500 is an internal server error. The next line indicates no caching is being used. This is an optional feature for a web server which can be used to improve performance. As for the request, the response includes a connection line, which indicates that the connection should be kept alive, allowing another request to be sent by the user. The content type is shown as text HTML, which indicates that readable HTML data follows. The server line provides information on the server's configuration in this case telling us that the HTTP server is built using WebBrick and Ruby and showing their versions. The next line in the header is content length and indicates the length of the following HTML code. We then have a line starting with set cookie, which provides the session ID. This is being used to provide session information for the web application. By using the cookie, I'll maintain authenticated access into the web application throughout the session. Following this is a series of requests and responses which access the various resources from the server, the style sheets, images, scripts, and so on. In this we can see a request header line for the referrer. Referrer logging is used to allow websites and web servers to identify where people are visiting them from, for marketing or statistical purposes. Using the referrer field can be a privacy issue, and most web browsers will omit this, particularly those using HTTPS. We can see the user login request, and we can see that the credentials are being sent in plain text. This might be a problem, as it will enable anyone intercepting the traffic to log into our account. We can see below this a GET request to obtain our John Doe picture. Given we don't have one loaded, we see the server returns an error code 404 to indicate the resource does not exist. While websites often just use a few, there are a lot of header fields that have been defined in the HTTP standard. The web page shown here is an excellent quick reference for all the HTTP header fields that you might come across during testing.